In this episode of Engine Week, we speak with Continental Aerospace Technologies about their Titan line of experimental aircraft engines. Due to a few travel restrictions, we interviewed Continental remotely. So let's dive in to the details of the Titan line of aircraft engines. Everybody, welcome to an episode here on Engine Week, Experimental Aircraft Channel. And today we have on Continental Aerospace Technologies. So more engines for you today. And JB is going to talk with us today. JB, you want to introduce yourself?
Sure. My name is James Ball. I work for Continental Aerospace Technologies, Titan Engine Division, Engines for Experimental Aircraft. I go by my initials. Most people know me by JB.
Excellent. Well, I'm happy to have you on today, JB, and thanks for carving out some time during your day to talk to us about what you have to offer there for engines. So let's dive right into the questions that I kind of put together for you guys, and that is what engine models and horsepower rating are available today through Continental?
Okay, these experimental engines are four-cylinder engines with displacements. Our flagship engines are displacements of 340 cubic inches or 370 cubic inches. What they are a stroked engine. In other words, we've taken what had traditionally been a 320 cubic inch engine. We lengthened the stroke on the crankshaft, and for the 370, it was traditionally a 360. We stroked that crankshaft to a 370. So you get the same dimensions, a very similar weight and the same dimensions as what these engines traditionally had been, but the additional horsepower that you realize from the stroked crankshaft, the additional displacement. They're available with each one are available with two compression ratio pistons. There's a low compression and the high compression. Of course, the high compression is the higher horsepower.
Okay. So just a quick list of how many different horsepower options are there then? The high compression and non-compression or non-high compression?
The 340 is available with a low compression at 174 horsepower.
Okay.
The high compression is 180.
Okay.
And the 370 low compression is 187 horsepower. And the high compression 370 is 195.
Nice. Very nice. All right. How are these engines equipped as a base, and what options are available for upgrades, whether it's the engine itself or bolt-on accessories and that kind of stuff to it?
Sure. The base engine has a lot of unique features. Standard are the roller lifter valve train, the lightened nickel carbide or NIC3 electroplated cylinder barrels.
Okay.
Thrust washer equipped crankcase where the thrust forces of the crankshaft are transferred to the case, steel on steel rather than steel on aluminum, which was the earlier designs were and still are with our competitor, steel on aluminum.
Okay.
Ours are steel on steel. We offer the fuel injection, carbureted, fixed pitch or constant speed.
And on the fuel injection or carbureted, what are you offering? Do you have your own series or brand, or what third party are you using for it?
We offer the Airflow Performance.
Okay, Airflow Performance.
Or Precision Silverhawk fuel injection systems.
Okay. And for carburation?
They're Marvel Schebler carburetor.
Got it. Standard.
Yep. Now the 340 takes an MA4-5. It's a little larger than your traditional 320 carburetor.
Mm-hmm.
The 360 carburetor, and that's to get enough fuel to that engine because of the power that it makes.
Okay. And what are you using for, or do you sell an exhaust system with this as well? What was an option? Not just the engine itself. Okay. Hey everyone, let me take just a moment here to thank our sponsors that make all of this possible. Great companies like Airworx, Airtech Coatings, Clemens Insurance Agency, ACME AERO, STOL Creek Aviation, NFLIGHTCAM, Whelen Aerospace Technologies. So take a moment after this video to say hello to all of them, and remember to check out the affiliate links in the description below. And remember, just build it. Let's get back to it. Is there a, while I'm on that topic, is there kind of a go-to that people are using, that you're hearing that you're using out in the field when they purchase your engine?
A lot of folks go to Vetterman,
Okay.
exhaust up in South Dakota, and Aerospace Welding in Minnesota.
Okay. I've heard both those names quite frequently myself recently, so those must be the top two.
Yep. Other features or options.
Okay.
I mentioned the constant speed prop setup. We manufacture a crankcase where that prop governor can be mounted in the front of the engine. There are quite a few airframe designs that don't have adequate firewall clearance for a rear-mounted governor.
Sure, they're all the way up against the firewall a lot of times,
Exactly,
right?
yeah.
Yep.
Another standard is our angled oil filter adapter. It makes it much easier and cleaner to change the oil filter. It's not sticking straight out. It's very, very convenient to be able to access your oil filter with our design. Lightweight, that's one of the foremost advantages. Our cylinders are lightened by tapering the steel cooling fins on the outside of the cylinder barrel.
Okay.
From wide diameter at the cylinder head to the narrower diameter towards the crankcase. And our induction systems. If it's a vertical induction, our magnesium oil sump weighs 7 pounds less than the traditional aluminum design. And we also have a forward-facing cold air induction system where the air plenum is separate from the oil sump so that heat's not transferred to the air as it passes through the system. And those two are made from magnesium.
Okay. Okay. I assume you're using some type of lightweight starter as well?
Yes, we have a number of options for starters.
Okay. And so what is, going to the 340 or the 370, what would be a, I guess, posted weight and then maybe an installed weight? I know there could be options, but like maybe an average, so builders know roughly what to think of the weight on the nose of their airplane.
Well, because we have so many options, it's hard to pin that down, but from 259 pounds on the light end
Okay.
to 296 on the 370. The 340, I think they're the heaviest is probably 265.
And the 296 would be fully loaded up with probably all the options, including a variable pitch performance prop controller and stuff like that.
Yeah.
Right.
Yeah.
Right. Okay. All right. Excellent. Excellent. And
The 370 is a counterweighted, has a counterweighted crankshaft, and it weighs a little bit more than a fixed pitch.
okay, but smoother running.
Yep.
Due to that, sure. So we got the 174 to 195 horsepower power ratings on this, and I'm always curious. I know how the automotive world works and racing engines and that kind of stuff. Do you guys have a dyno set up to determine these horsepower ratings, or is it all just a calculated math equation to push this out? How do you all get to the horsepower rating, or how is that obtained?
Well, a little history here. Continental Motors bought a company called Engine Components out of San Antonio, Texas, where a lot of this was developed.
Okay.
And over there in Texas, we had a water brake dyno. So we actually dyno tested them, but not at sea level. We were up probably 1,200 feet above sea level there. When Continental bought the assets and transferred the manufacture of these parts to Mobile, Alabama, they ran similar engines on their dynos, or our dynos here. So they weren't water brake. They're a different type of dyno, but yeah, we got some baseline dyno data. And when we rate these engines, it's rather conservative because there are things that improve the performance, electronic ignition, cold air induction that I mentioned,
Sure.
and so forth. So it's
Things
hard
that help keep those numbers in line to create that baseline, as you're saying,
exactly.
versus all over the place. Yeah.
The more horsepower and some are a little less.
Well, that's good to hear, because I know some companies have like, well, this is our 100 horsepower model. Well, does it actually create 100 horsepower, or we're just rounding up? You know, I would hope that you would round down than up. So having legitimate, and then of course, you know, depending on where you live and where you fly out of and what altitudes and stuff, that's all going to change as well. But the baseline would be sea level to 1,200 feet or something like that, right? So that's the horsepower. What is the recommended TBO of each of these, and how can an owner reach that timeline or beyond with little to no major repair replacement of components? Just doing the basic maintenance or whatever the routine maintenance is, suggested maintenance, I guess.
Yeah, the TBO is set at 2,000 hours. Of course, with experimental, it's a recommended TBO. It's not a requirement.
So I mean, your certified would be at 2,000 hours, and the non-certified is beyond.
Correct.
Right. Okay.
But we published it at 2 as a suggestion. Routine maintenance and regular use of the engine are the main things that lend longevity to an engine.
Okay. And other than changing the oil and cleaning the spark plugs on this type of engine, what would that be? It's not like a car where you're going to change a timing belt and a water pump at 80,000 or 100,000 miles. So what would be something that you would do other than oil changes and spark plug cleaning and stuff like that, and oil filters?
Yeah, oil filters, fuel filters, air filters. But other than that, changing the oil, using good quality fuel, and flying regularly, and not just ground runs, but getting up in the air and getting the engine up to temperature are the best things for these engines.
Okay.
Uh,
I'm going to skip ahead to one of my other questions I had here, but since we're on this topic, what fuels can be used on this? Can you use everything from MoGas to 100 low lead to something else? Do you have to add anything to the fuel or the oil to help with lead? Talk to me about that for a minute.
Well, 100 low lead is recommended for all Titan engines.
Okay.
We have the low compression options. A lot of people utilize MoGas, non-alcohol MoGas for their engines in the low compression configuration. But we strongly recommend that those that do put some 100 low lead through the engine from time to time, because the lead salts that are deposited have a very beneficial effect. Lubricity of the valve guide and valve stems, cushion on the valve seat to valve interface. So having some lead doesn't take much, but having lead in these engines is very beneficial. But we have not tested. We don't. There are so many formulations of MoGas that it's difficult to pin down exactly what formulation we would approve. So at this point, the official line is 100 low lead exclusively. If you're going to use MoGas, go with a low compression engine and run some 100 low lead through it from time to time.
Yeah, because depending on where you are in the world, that octane rating may mean something completely different compared to over here, right? So then you'd have a problem with detonation, possibly, depending on where you're at.
That and vapor pressures are different between different fuels. It's a whole science in and of itself.
Yeah, I started to dive into that a little bit. I got a slight education on that, just around the world, how much it dips. Octanes go pretty low in other countries, well below 87 octane that we would use in our cars and stuff like that. So, okay, good to know. Use 100 low lead and stick to that. All right, going into the experimental class here, do you offer any owner maintenance programs or classes on how to properly maintain the engine? Like, the sport aviation light sport class, they've got this like repairman's class to take. Is there anything like that for these engines to help either do the simple maintenance or to dive in a little bit deeper into, other maintenance on the engine?
We have a division of the company that has tech support.
Okay.
And our tech support gentlemen do conduct training programs for avgas engines, not specific to these experimental engines, but to the Continental lines of legacy engines.
Okay. Because that's the other added benefit or difference, right? From a certified airplane to an experimental, you build it, you get the repairman certificate, therefore you can work on your airplane and do the condition inspection, as they call it. But then there's the engine. Do you have to bring that back to an A&P to work on the engine? Or can you gain the knowledge enough to be able to do at least some of the stuff through, learning from you or buying a book or whatever? Just want to know if there's something out there.
Yeah, you don't have to be an A&P mechanic to maintain your own engine. And we have the resources for people that have questions or any tech support related inquiries on staff. We're always available to them. If someone wanted to attend one of our seminars at Oshkosh or Sun and Fun, whenever we someday get back to that.
Right.
There's a lot of information to be gleaned from those seminars as well.
Okay. Is that typically where those are held at the big events, or do you do any at the factory or at your sister location there in Fairhope?
We do some here at the factory.
Okay. And they could just call you directly to inquire about that on the training?
There's a way to sign up for it through our website.
Okay. I'll share that here. So in 2020, obviously things change year to year sometimes, but just to give a ballpark idea, understanding you got a lot of different options available from the 340 to the 370, what would be kind of the price points, maybe from low to high on each, like a base and then fully loaded up with options to give builders and people an idea of what to expect to purchase one of these?
Well, as you know, we're going into a new year, and there's going to be some changes in pricing. It's hard for me to pin down exactly. If in round numbers, you're around $30,000, depending on how you configure it. It could be a little less if it were carbureted, a little more if it's fuel injected. Just depends on how it's equipped. But,
okay. And is that pretty much everything, a running engine minus the exhaust, or what would be included in the ballpark 30 grand price point?
Running engine, and I'm glad you mentioned that. We do run them in here at the factory for 3 hours to help get the break-in off to a good start.
Okay.
It's a running engine. There are options. We don't supply an oil cooler. The oil cooler is not supplied. The exhaust. We do have some alternators. If a guy wants to have us supply the alternator, we can. We have the spline drive alternators that mount on the accessory case in the back. They're kind of a 20 amp backup alternator. And then the belt driven ones from the front. Those are optional. So those things add to the cost.
Sure. Okay. Good to know for that. Where are the parts made? And if you could explain a little bit about the FAA PMA process for certified, or in the case of experimental, how a part origination is handled, or how part tracing or tracking is handled if it's non-FAA PMA'd.
Continental designs and manufactures all the components here in our state-of-the-art factory under very stringent guidelines. They're manufactured to the same standard as our legacy parts.
Okay.
And in fact, the Titan engine, 99%, well, 90% of it is made up of FAA PMA approved parts.
Yeah, I would assume that if you went through the process of engineering a part, getting the FAA PMA approval, that even though it goes experimental, it probably could just go from this shelf to that shelf for experimental, not the opposite direction, of course. But it's probably the same part. You just we'll stop right there for a second. Does each part have to be gone through the process, or no? Once that's established, then that's FAA PMA approved, right? So, is there anything? Is it a cost to you less for the experimental part versus the FAA PMA part?
No, they're all the same.
Okay.
They're all the same. The approval process is where the expense is.
Sure.
Certain items like the crankshafts, the stroked crankshafts are not a certified part. So the development and approval process was less expensive at the time.
Got it. Probably manufactured or sourced from the same places, just not the paperwork involved.
Exactly.
Okay.
So, yeah, they go through the same quality system as all the other certified parts go through.
While we're on the subject of crankshafts, can you explain a little bit about is this hardened, nitrated, or anything like that? Is there anything specially done to the crank to make it as strong as it is?
Well, they're a VAR steel, which is a vacuum arc remelt. In other words, the forging is done in a vacuum so that contaminants from the air aren't introduced into the steel. And then they're brought in and machined and surface nitrided to harden up the bearing surfaces.
Okay.
And they have the thick flange, the thick prop flange. Most are suitable for aerobatic applications. They're just a good crank.
Got it. All right. Another question I had for you. I've kind of heard or seen or read through the grapevine over the past year or so, or years, that there is a diesel engine. You know, people are wanting to do other options other than Hunter low lead. In some other countries, avgas is either really hard to come by or really expensive. So I see the need for a diesel or Jet A powered. Are you guys working on a diesel engine? And if so, how's that coming along, or what's that look like?
Well, Continental and our partners have reached a lot of milestones with the Jet A powered engines in the certified world. Recently, we launched the CD170 and the Tecnam P210. At this point, we're not pursuing the experimental market for Jet A powered engines, but if you have an interest in that, if someone really would love to have it, we suggest they talk to the airframe manufacturer and pass that desire to them so that they can prompt us and perhaps make something happen in that regard.
Okay. Yeah, I wonder, with all this talk of electrical, designs and batteries, if they're going to skip over that and go straight to electric, right?
I don't know. It could happen.
Tell me more. Come on. I'm sure you know something. All right. Well, that pretty much is the answers I had written down. If people wanted to call and get information or kind of get some more information about this on their own, where's the best places to either read about it or check out your website on these either certified or non-certified experimental models?
Yeah, there's a section on our website for experimental engines.
Okay.
There's also documentation for product support there. I'm available all the time. I quote all day long. I work with people to configure the engine that they desire to make it their own. And a lot of guys are building their custom aircraft, and they'd like to have an engine that they've been involved in the configuration of, and that's what I do. I try to give them what they're really interested in having. So
awesome. Well, again, I appreciate you all jumping on with me today and sharing a little bit about what you have to offer there and the history, and look forward to dropping in hopefully in the near future and being there on scene myself, and we can see some of these engines being broken in or something.
Yeah, you'd be welcome to come and visit.
All right, everybody, thanks for joining us today. If this is your first time here, I invite you to like this video, this episode, and consider subscribing. I'll see you in the next episode. Thanks for watching this week's episode on our Engine Week series. Return tomorrow to catch our next episode here on the Experimental Aircraft channel. I'll see you in the next episode. Thanks for watching.